All right, let's take a look and see where we're at here. Looks like most people are fairly close to being done, or at least most of the way done. Like I said, these problems are kind of practice problems of things you'll see on the test. I think I told you last week. If not, I'll just refresh your memory kind of quickly. So here's kind of what your test will be made up of. On the algebraic connections portion, you will have a factoring problem on there. Okay, I've told you that multiple times. So just be aware, that's why they keep coming back in the warm-ups, so that you're continually practicing that every time I see you. And then obviously there'll be some other algebra-related problems there. Second, the geometric connection standard, the one that is weighted the heaviest, that one I will tell you is all trigonometry. Okay, the whole standard is anywhere from law sines, law cosines, right triangle trig. Could be using the shortcuts if you remember them. Or like I said, if you don't remember the shortcuts, that's fine too. Then you can kind of get around just using trigonometry. But that standard will be all trigonometry, okay? And then the newest standard, the geometric reasoning stuff that we're talking about, that one is basically two things that you're going to be taking a look at. There's two main ideas from the current chapter. Number one, if I give you some triangles, can you tell me why they're congruent? Okay, side angle, side angle, side angle, which shortcut we're dealing with. And number two, can you then write a proof that goes along with it? Okay, and so the proof side of things is, there's two proofs. I was just finishing up the test over the weekend. We decided to put two proofs on the test. Okay, so just a heads up, that's what you'll be responsible for this chapter. Can you tell if triangles congruent, and can you write a proof showing that triangles are congruent? That's the idea. Okay, so if we take a look at this one, I'm hoping in numbers 1 and 2 here, I'm hoping that you looked and right away a couple of things clicked. Notice right away they're both right triangles, so I'm hoping you fairly quickly thought, oh, I've got to do like sine, cosine, tangent, something along those lines. And in number 1, since I'm solving for an angle measure, what's going to happen somewhere in this problem? What kind of problem is this since I'm looking for an angle measure? Okay? Yeah, we're going to use inverse trig in here somewhere. Okay? And so if we take a look, 8 is the leg opposite the angle I'm looking for. 12 is the hypotenuse. And therefore, opposite and hypotenuse, that means this is a sine problem. We take the sine of x equal to, by definition, opposite leg to hypotenuse. So in this case, 8 over 12. And now here's where the inverse comes into play. In order to get that x by itself, I got to get the sine out of there. The opposite of sine is inverse sine. So if I take the inverse sine of both sides, that'll leave me with x on the left-hand side. It cancels out the sine. And then on the right-hand side, we'll have the inverse sine of my fraction, 8/12. And now x is by itself, and we can type that in and get an answer, okay? So in this case, what do you get for x? Rounded to the nearest hundredth. What did somebody get? What is it? 41.81. Agree, class? Yes? Confirm? Okay, good. Good. 41.81 degrees, approximately. So there's your first one. Turned out to be an inverse sine problem. We take a look at the second one, also a trig problem. The only difference is now I'm looking for a side length, so I don't have to use inverse trig in this one at all. I can just use regular right triangle trigonometry. So if 51 is my angle that I'm using, my reference angle, x is the adjacent leg, 22 is the hypotenuse, and adjacent and hypotenuse, that's your cosine ratio. So if we set that one up, we get the cosine of 51 over 1 equal to, by definition, adjacent over hypotenuse. And now from here, we set up a proportion, and now we solve it. We cross multiply, x times 1, that's just x, equal to the other diagonal, 22 times the cosine of 51. And once again, x is already by itself, and therefore we're ready for the calculator. And in this one, I know it's less than 22 because that's the hypotenuse. What do you get for that one? Yeah, Grace? 13.84. Okay, agree? Yeah. Okay. See some people at 13.84. Thank you, Grace. And there's our answer to that one. Okay, so this little bit of geometric connections, going back to an inverse trig again, going back and doing some right triangle trig. just constantly working back on old stuff while we also work on new stuff. Before I move into the factoring one, any questions on either of these? Anything that you want to go over? Anything not make sense, I guess? Okay, like I said, I know we've been working on this stuff for a while, so I'm hoping you're feeling fairly comfortable with the trigonometry stuff. Then we get into the factoring portion, okay? And remember, it's a 3-step process every time. We start off, we put our 2 sets of factors down. We always start with factors of your first term, okay? So in this case, I could have 12x and 1x. We could have 2x and 6x. Or we could have 3x and 4x. I'm going to start with the 3 and the 4, just because they're the 2 closest together. So we're going to start there, 3x and 4x. Then, step number 2, we go to the other end. We go factors of your constant term, factors of your last term. In this case, it's either 1 and 6 or 2 and 3. Again, I'm going to start with 2 and 3, just because they're closer together. Okay? So if I put the 2 and 3 in there, and then remember, the whole rest of this problem is you're checking the inside and the outside 2 terms to see if we have the right combination to get that middle term. Okay? So in this scenario, if I multiply the inside 2 terms, I get 8x. If I multiply the outside 2 terms, I get 9x. Is this the right combination? No, this isn't going to work. I'm either going to get 1 or 17, depending on the signs. Okay, so that's not going to work out. I need 22. So, next step would be to go through and switch. Put a 3 here, put a 2 there. Okay, flip-flop the factors and see if that works. Check again. Inside, I get 12x. Outside, I get 6x. How about that one? Is that going to work? Nope, that doesn't work either. There's no way from those I can get a 22x. So unfortunately, so far, 2 and 3 didn't work in either order. So now I'm going to go back to the other set of factors. We said we've got 6 and 1. Okay? And I'm going to put the 1 and the 6 in here, and we'll try again. Really, the whole rest of this problem is just kind of trying to find the right combination. So inside gives me 4x. Outside gives me 18x. How are we doing? Does that work? Yep. As long as they're both positive, if I put those together, I will get 22x. So I need a plus sign and another plus sign. And so now, and again, this is always a really simple thing to forget, but again, you're going to hear me say it every time we do this. Don't forget, I factored. I did not solve yet. Okay, I'm not done. I'm done with probably the harder part of the problem. I'm done with the factoring portion, but now we got to finish it. I need actual solutions. So zero product property. Take each factor and set it equal to 0, and then we're going to solve. And now we solve each equation separately, and that'll give us our 2 answers. First one, we subtract the 1 over. I get 3x equal to -1. Divide both sides by 3, and we find out that -1/3 is my first solution. There's my first answer that we have. Then we go to the other portion, subtract the 6 over. I get 4x equal to -6. Divide both sides by 4, and x equals -6/4. Just a quick heads up, general rule of math, if you can reduce, you should. Okay? Now, if you put -6/4, let's say on the test, would I mark it wrong? No, but I would probably make a note and say, hey, don't forget to reduce this. Okay? So if we reduce that, you get a final answer of -3/2 as your final answer there. Okay? So general rule though, if you can reduce, you should. So -3/2, -1/3, those are the 2 solutions that would make this equation equal to 0. And like I said, you will have a factoring problem on the test as well next week. Okay? Questions on that at all? We're doing okay? All right. Well, we'll leave it at that. Like I said, mostly, pretty much the warm-up every day is just kind of older practice problems. Every now and then we throw in some newer stuff, but we didn't necessarily want to throw in a proof as like a practice problem. Okay? So next thing I want you to do is take out your congruent triangles proof worksheet that I assigned over the weekend here. Take that out. I just want to kind of talk through some things. Mainly because as you were working your way through some stuff, and as I was grading some things, Some people were doing just fine, but there were still quite a few mistakes yet that I just want to make sure we clear up as we move through the chapter. So my hope is that the first page was fairly straightforward, and the reason I say that is almost everything on the first page was given information. Okay, you didn't really have to come up with much. For example, the first one, you've got side angle side given to you in the picture. You don't have to come up with any extra congruent angles, any extra congruent sides. And so, but the heads up that I want to give you is, remember, you got to put each thing you know, you got to put it down one step at a time. So for example, if I just put this first one together quickly, I would take a look at the picture and say, step number one, I'm going to go with the one congruent marking. Segment LZ is congruent to segment AI. How do I know those segments are congruent? Congruent, number one, is given in the picture. Okay, that part's given. There's one set of congruent statements. Then I would go to step number two and say, all right, now I'm going to go through and I'm going to take the second set of congruent statements. Segment LU is congruent to segment DI. How do I know those are congruent? Also given in the picture. Okay, so there's a second given in the picture. Then we go to step three. There's another piece of the given information. We've got two 65-degree angles here. So I'm going to state that angle L is congruent to angle I, also given in the picture. Oops, step three. There you go. And now here's one thing that I noticed as people were turning stuff in. Okay? Some people were going through and finishing off the congruent statement up here, but then not putting it down here. Remember, that was just to kind of get you started. The proof, though, is all of this information is true because it's trying to lead you to some conclusion. And hopefully that conclusion, most of the time, is going to be that the triangles are congruent. So don't forget that step 4 of this proof, you still need to state that the triangles are congruent. Because right now, all you have is you've just got a bunch of congruent pieces. Okay? So the conclusion is that triangle LUZ is congruent to triangle. We match up the letters. L is the 65, so it's going to be A. U is at the end of the 2 marks, so it's going to be D. So in this case, it's IDA. And the reasoning, if you look up the information in the picture, one of our shortcuts, it is side angle side congruence. Okay, side angle side congruence. So there's an example. There is the first proof right there. Main reason I wanted you to see that is notice one step at a time with a conclusion of congruent triangles. Okay, so you got to put each thing in. Proofs are fairly detailed. As you work your way through it, you got to be careful. You got to do one step at a time. Only other thing I wanted to mention on this page, and I'll open it up as well to you, is when you get to number 3. This is the only proof where you actually had to come up with something on your own. Everything else, 1, 2, and 4 had all given information. This one, remember, there's a congruent, you've got a shared side right there. So in your proof, you would say segment CV is congruent to segment CV, either because of the reflexive property, or I told you before, you could just put down shared side, and that's fine. And then these 2 triangles are congruent by side, side, side. Congruence. Okay? So again, this should be 4 steps for each set of congruent sides, and the 4th one being that the triangles are congruent by side, side, side. Let me stop there real quickly on page 1. Any questions in general, or any questions specific to this page? This page seemed to be, for the most part, generally okay. Like I said, there was a lot of givens on it. Okay, let's go to the next page. This is where it got a little bit messier. On problem number 5, I think most people did a pretty good job on number 5 as you were turning this stuff in. If you notice right now, you've got 2 sets of congruent angles. So right now, as is, you know those triangles are at least similar. And the question is, can I come up with one of my congruent shortcuts from my red toolkit? Well, in this case, the only piece of information I really know that's true here is that once again, I have a shared side. The problem, though, is if you look at the top triangle, the information is angle, side, angle. If you look at the bottom triangle, it's angle, angle, side. Both of those are congruent shortcuts, but you have to have one or the other. You can't have one congruent shortcut in one thing and one congruent shortcut in the other. So this is one of the ones that is you're not able to prove it. Okay? Yes, there's stuff that's true. There's just not enough information to actually prove that those 2 triangles are congruent. They are similar. They got angle-angle similarity. And here's where it gets a little bit more confusing. 6, 7, and 8, I would say, are probably the ones that were the most confusing ones. So let's take a look at like number 6, for example. If we take a look at problem number 6, this is kind of a given, okay? You're being told that segment AT is an angle bisector, and therefore that then needs to go into your proof, okay? So some people that were going through and were doing the proofs saw that this was an angle bisector and then just went directly to the next step and started working their way through it. If you're going to be given some information, you've got to put that given information in your proof. Otherwise, if it's not stated here, it's not true, okay? It's not true unless it's in your proof, so make sure you're careful with that. So for me, step number 1 of this problem is I would say segment AT, and I'm going to abbreviate, is an angle bisector. How do I know it's an angle bisector? Because it's given. It says so. Okay, there's my reason. And now I can get something from that. There's my first given. Now, therefore, if AT is an angle bisector, what does that mean must be true in this problem? What's the result of angle bisectors always? Yeah, Connor? 2 equal angles. If it's an angle bisector, that means it's cutting angle A in half. So I know the result from that step is that this angle has to be congruent to that angle. That's what an angle bisector does. Cuts an angle in half. Okay, so step 2 on this one was I would state that those 2 angles are congruent. So angle SAT is congruent to angle LAT. And in this scenario, how do I know that those angles are congruent? The definition of an angle bisector. By definition, that's always the result. Okay, that was one of those things we talked about last week. Definition of angle bisector. Again, abbreviate. So like I said, as I was looking through assignments, quite a few people skipped that first step and went straight to congruent angles. And you have the right idea, but I wanted to give you that heads up that if it's a given, if you're told something up here, you got to put it in your proof. Okay? So we got one set of congruent angles. Then from here, there's actually quite a few different ways you could do this problem. I would go to the next given. You got a set of congruent sides. So personally, I would say segment AL, or LA, is congruent to segment SA because they're given. Given in the picture in this case. First one was given in words, the second one's given to you in the picture. And now, we have basically run out of givens. I've used the angle bisector, I've used the congruent sides, so now we come back to the idea of, well, what else is true in the picture? And what's the answer? What is something else you can tell me that is true about this picture? That has to be true. What do you think? One other piece of information that has to be true here on number 6. Connor, what do you think? Yeah, we've got a shared side again. Anytime there's a shared side, there's a pretty good chance that's coming into play. So segment AT is going to be congruent to itself. So there would be my step 4. Segment AT congruent to segment AT. And what's the reasoning? One of two things. You can either put shared side, or remember that's called the reflexive property. Okay? For now, I'll just put shared side. That's fine. And finally, now we get to the point where I have a conclusion. I've got enough information in that picture that I now know that the triangles are congruent because of side angle side congruence. Okay? And again, that's not the only way I could have done this. So you might have done it differently and also got it right. This is just the way that I decided to go about it. Okay. Let me stop for a second. Is this making some sense? Seeing some of the details that maybe you might have missed before, that now you're starting to see why they need to be in the proof, hopefully. Okay. As long as we're on this page, let's stay on this page for a second. Any questions that you want to go over 7 or 8 together at all? Either 7 or 8 together. Again, the one thing that I will tell you that I noticed, if nobody wants to go over it, that's fine. But the one thing that I noticed on 7 and 8 from the people that had turned it in already, don't forget to put the given in the problem, okay, in the proof. So in part 8, you would have to state that M is the midpoint of both segments. Then tell me what that means. What's the result from that? Over here, telling me that you've got 2 sets of perpendicular lines, which means what's the result of that? Okay, then you go from there and tell me what do you get from that information? What does that mean? And so just a heads up on that as well. All right, any final questions at all on like numbers 9 or 10? I told you number 11 was kind of more like a bonus problem. Any other questions on 9 or 10 that you want to go over? Okay, like I said, you will have 2 proofs on the test. Okay, so you want to make sure that you understand this. You want to make sure that you can work your way through a proof fairly comfortably, so that you can, when it comes time to the test, you can perform on that. Okay. All right. If we take a look at the lesson then, and you don't necessarily have to take notes on this lesson, just kind of follow along with me. It's a fairly short lesson. That's why I haven't rushed into it with a fairly straightforward concept. Okay, because it's kind of setting up the next lesson is really what's happening. So section 615, you notice we're going to talk about something called a converse. And this first paragraph actually pretty much tells you the main idea. So far in this chapter, we've completed several problems in which we were given certain information and had to determine whether triangles were congruent. We've been doing that the whole time. But what if you already know that the triangles are congruent? What information could you conclude then? Thinking this way requires you to reverse your triangle theorems. Okay? And today we're going to look more generally at what happens when you reverse a theorem. So for example, we said, like side congruence. If all 3 sets of sides are congruent, then we know the triangles have to be congruent. Now we're going to look at it from the other perspective. If I already know that the triangles are congruent, let's say that was a given, or I've already proven it, well then, what does that tell me? What can I get from that? Okay, that's what we're going to take a look at. And that is what is called a converse. The converse is the reverse of whatever statement you're talking about. So let's take a look here. In 641, so it says Jorge is working with the diagram at the right. So he's working it with his top diagram. And he concludes that line AB is parallel to line CD. That's his conclusion. And he goes through and he'll conclude that those lines are parallel. And he writes this if-then statement, this conditional statement. If alternate interior angles are equal, then the lines are parallel. First question, is that a true statement? Did he come to a good conclusion? What do you think? If alternate interior angles are equal, does that mean the lines have to be parallel? Yeah, because that's the only time alternate interior angles are equal. Okay, they're only equal if the lines are parallel. So this is a solid conclusion. Okay, then if you take a look down here in part A, it says Margaret is working with this next diagram. She concludes that x equals y. And it asks you to go through and write either a conditional statement or an arrow diagram. So here's the question, here's the idea that we're getting at. In the first one, we knew that alternate interior angles were congruent, so we concluded parallel lines. In the second one, we have parallel lines, and therefore are concluding that alternate interior angles are equal. Those two are an example of a theorem and its converse. If equal, then parallel lines. If parallel lines, then equal. The idea is if you just switch the if and the then around, you have the converse of a statement. And I will tell you in advance, you can always write the converse of a statement. It's not always true, however, and that's what we're going to take a look at today. Okay, is when are they true? How about this one? If lines are parallel, then corresponding angles are equal. So first question, is that a true statement? Is that a true if-then statement? If you've got parallel lines, then corresponding angles are equal? Yes, maybe, no? What do you think, Dennis? Is that true? Parallel lines, corresponding angles are equal? Sure, perfect. Guessed correctly. Yes, that is a true statement. Okay, so now if I write the converse, here's what I was talking about. Let's just kind of write this one out. If I switch the if and the then, we have the converse. So I'm going to quite literally just put those in different spots. If abbreviate here, corresponding angles are congruent, then the lines are parallel. Okay, that would be the converse. If parallel, then equal. Converse is if equal, then parallel. And the second question I have for you is this also a true statement? What do you think? Is this a true statement? If corresponding angles are equal, when you look at a picture, does that mean the lines are parallel? Yeah. So this turns out that it is a true statement. Okay, here's where we're leading into. Here's where we're going to use it going forward. Okay, so this problem is what I would say is the main problem of this lesson. Okay, we take a look. They wrote their if-then statement with what's called an arrow diagram now. The first part is the if, the second part is the then. They just used an arrow instead of an if and then. So, if you know that two triangles are congruent, can you conclude that corresponding sides are congruent? What do you think, Nick? Yeah. Think about what a congruent triangle is. Same size, same shape. They are identical. So therefore, this would be a true statement. So now what I want you to think about is the converse, okay, the opposite. What if I flip these around? If you know that the sides are congruent, is that enough to know that the triangles are congruent? Think about it. Think about what's on your red toolkit. Is that one of your shortcuts, if you think about it that way? Connor, you say yes? Which one are we talking about? Yeah, this is the definition. So the converse of this would be, yeah, if the triangles are congruent, I know the sides have to be. But side congruent says, if the sides are congruent, then the triangles have to be. Okay, so in this case, the converse is true. Let's go one more step. If we take a look at the next one, here's another example down here in part C, right here. If you have congruent triangles, they are making the conclusion that means that the angles are congruent. Okay, not corresponding angles like parallel lines. Just saying like angle A from one triangle to angle X from the other triangle. Okay, the ones that match up. Is that a true statement, by the way? If triangles are congruent, the angles are the same? Yeah, right? Okay, same angle, same side lengths, everything is the same. Now let's do the converse. If the angles are the same, and that's all you know, if the angles are the same, do the triangles have to be congruent? What do you think, Amanda? They don't have to be congruent. They do have to be what, though? They are similar. That's enough to know that the triangles, remember angle similarity? It's enough to know the triangles are similar. It is not enough to know that the triangles are congruent. Okay? So in this case, the converse of that statement turns out that it's not true. If all you know is you've got congruent angles, matter of fact, let me go back for a second. Right here. Here's an example of it right here on number 9 of your worksheet. There's 1, there's 2, And then you've got a third set of congruent angles right here. Those are vertical. Well, there's 3 congruent angles. Nothing, that's not one of our shortcuts. Yeah, those triangles are similar, but there's no way to prove that they are also congruent to each other. Okay? So number 9 on your worksheet is another one of those that cannot be proved. Similar, but not congruent. And that's the idea that we were just talking about right here. Okay? All right. Let's go one step further. I'm going to kind of skip over a problem. And let's go to this one. We'll kind of wrap it up with this one, and then I'll give you a little bit of time in class to get some work done. We'll go from there. All right. So here is where we are headed. So Raj is solving a problem about 3 triangles. He's trying to find the measure of angle H and the length of HI. Okay? So he's looking at this picture over here. He wants to know what's that angle and what's that side length. Okay? And therefore, he summarizes the relationships that he's found so far in the diagrams. And it says, help him out. Can he figure it out based on this? So let's start at the beginning and just kind of work our way through it. See what we know. First question, are the first 2 triangles congruent to each other? Are these 2 triangles congruent? Do we have any of our shortcuts? Lennon, you say yes, which one? Close. You do have side angle side here. And you do have 2 sides at an angle, but it's not side angle side. It's not the same parts. Now, what do you think? There is side though. It's a different version. It's kind of a unique version. They told you got 2 sets of congruents, and then they told you that the 5s, therefore, also congruent. So it turns out that, yeah, these 2 triangles are congruent by side. So therefore, tell me something else you know about the second triangle. Now that you know the triangles have to be congruent. One other thing that I know has to be true in that middle triangle right now. What is it, Jamal? You think, you know? That's exactly it. If these triangles are really congruent, that means they've got everything is the same. So that 60-degree angle, well, that has to be 60 degrees then, because they're identical to each other. All right, now let's go from here to here. So these 2 triangles were congruent by side congruence. Okay? How about these 2? Are these congruent? What is it this time, Lennon? Now I've got side angle side. If you take a look, side angle side, side angle side. These triangles are congruent by side angle side congruence, which, remember what I was trying to do? Angle H and the length of HI. What's the measure of angle H? What is it? Yeah, Jacob? 60. Yeah, if that's 60 and it's congruent to that, that means that's got to be 60. And if that one's congruent to that, that means this has got to be 60. Found one of them. And what's the length of HI? Keep going, Jacob.
I'm sorry, what was the question?
What's the length of HI?
HI? Oh, that's just 5.
Yeah. This is 5, and that's 5, and therefore, that means that has to be 5. And there's the 2 pieces of information that I was looking for all along. Okay? And so this problem, this idea of this problem is, if these triangles are congruent, that means all the parts have to be congruent. The 60-degree angle kind of comes along, the 5 comes along for the ride. Congruent triangles means that their parts are also congruent. Okay? And that is not only one of the main ideas for today, it's the main idea lead-in for Wednesday. Okay? All right. So last thing, and I'm not going to spend much time on this, but there's a math notes box here in the lesson that talks about the converse of a statement and the idea of switching the if and the then around. Okay? It's kind of a summary of just what is a converse. It's just the reverse. Okay? And here is your practice to learn for today. I'm not going to let you go yet. I'm going to keep you for another 7-8 minutes yet. But so 615 worksheet. However, you can skip problem 651. So if you want to cross that one off right now, you are welcome to do so. And I'm going to give you about, like I said, about 7-8 minutes here to go through. You can be working on any of the worksheets. You can be working on Delta Math. I gave you G20 last week was the Delta Math that's due for this Friday. You can be working on that. And I will just come around and check in with you and see if you have any questions or where you're at until it's time to go. Okay? All right, go ahead and go to work.